Hey everybody. Today we're going to be going over one of the more challenging kinds of analyses in statistics that you'll be learning this semester. But that means after you get through this video and after you master these concepts, basically you're going to be at the top of your game for not only the rest of the semester, but even for going out and getting yourself into a career or graduate school or whatever you'd like to go on to do after graduating. So let's dive into it. What you can see here is we've got a larger data set. We've got 24 participants, and we've collected data on a number of variables. So it looks like we have relationship status. Some people are in a relationship now, some people are single, some people say it's complicated. So this is going to be a variable, a categorical variable with three different levels, right? Three different levels: in a relationship, single, or it's complicated. We've got a couple of other categorical variables. Breakup, whether your last breakup, you were the person who did the dumping, the dumper, or if you got dumped, that would be the dumpee, right? Attachment styles, insecure versus secure. So both of these variables have two levels to them, two levels to them. And then we have a number of numeric variables: loneliness felt at your previous, the most recent breakup versus loneliness currently versus satisfaction currently. Higher numbers indicating higher scores, more loneliness or more satisfaction. So let's say I have a hypothesis that people who are currently in a relationship are going to feel less lonely now, but that's going to depend on whether their last breakup they were the dumper or the dumpee. So I'm gonna say that people who are currently in a relationship and did the dumping, were the dumper of their last breakup, are currently lower in loneliness than any other group, essentially. Okay. So what we're looking at is the interaction potentially of relationship status and the previous breakup, whether you're the dumpy or the dumper. Okay. In terms of loneliness. Now, status has three, the status is going to be a factor and it has three levels. Breakup is a factor and it has two levels. So what kind of design do I have here? This is going to be called a 3 by 2 design. 3 by 2, because it's three levels in relationship status, two levels in previous breakup, and so it's a 3 by 2. So, all right. How do we start? Well, we're going to do all of this in RStudio, and I have already imported these data into RStudio. So we are ready to rock. The first thing that you want to do is we're going to create a factorial ANOVA model, okay? And you could name this model whatever you want. Um, Maybe you will name it something like loneliness one or relationship status one or, you know, I don't know, whatever you want, like whatever food sounds good to you right now. You can name it that if you want to. I'll just put, I don't know, status one. You could name it model one. You could name it whatever you want. And then we're going to put this little less than sign and a minus. Looks like a little arrow. AOV is analysis of variance. You saw that in a previous video. Now we're going to ask R to actually compute three separate tests, essentially. We're going to ask it to look and see if there are any differences in loneliness now across any of the relationship statuses. So in a relationship, single, or it's complicated. See if those folks, any of those groups are different on loneliness now. We're also going to ask it, that's called a main effect of relationship status, a main effect. We'll also ask it for a main effect of breakup, which will ask it to say, hey, in terms of loneliness now, is there a difference between the dumper and the dumpee in the most recent breakup on average? And then we'll also ask it for an interaction, a test of an interaction between these two factors in terms of loneliness now. So what we're going to do, you start with the dependent variable, and in this case, we have to specify our data frame, which is called factorial ANOVA. You put in a dollar sign to say which column you're talking about. We're talking about loneliness now as the outcome that we're interested in. and then you put in a little tilde, and then you're going to put in the first independent variable. So we go factorial ANOVA, and we're looking at status, relationship status, plus. So this would just say, hey, give me the main effect for relationship status in terms of loneliness now. But now that we're doing a factorial ANOVA, we've got more than one factor, more than one independent variable. So I'm going to add to that again, factorial ANOVA, and then we get the dollar sign in there and breakup. Okay, but we're not done yet. That's just both of the potential the main effects, right? But we also want the interaction. So I'm going to add to that. You put in, and I know this is a little much, but we're going to go, oops. Factorial ANOVA is the data frame. We're going to go status, and then you put in a colon, and this is saying status by breakup, status by breakup. That's an interaction term. So I'm going to do this again. I'm surprised it's not letting me do that. Okay, and now we're going to go breakup. Okay, so that should be all we need to do for now. I'm going to hit enter, and you can see that it added status one as a model up in the data. So that's good. That's what we want. Now we're going to have to actually get it out and see a summary of it. So I'm going to type in summary of status one. Hit enter. Beautiful. Okay. So this is essentially three different tests all at the same time. This first row, factorial ANOVA, dollar sign status, is saying within the status independent variable or factor, tell me how each of these groups, or whether any of these groups, any of these three groups, are different in terms of their loneliness now. And we can see if we go across to the p-value, the p-value 0.00117, that is less than 0.05. So that is significant, meaning that one of these, at least one of these group means, is different than the other group means in terms of loneliness now. We don't know which one because basically this is kind of an omnibus one-way ANOVA test, if you want to think about it that way. This next row, factorial ANOVA dollar sign breakup, this is again asking for a main effects of breakup. Well, there's only two levels of breakup. So essentially, this is kind of like an independent samples t-test. And what we can see here is that it is not significant. So the p-value is 0.138, 0.139. That is higher than 0.05. So that is not a significant test. The interaction of status, relationship status, and breakup in terms of loneliness now, the p-value is 0.370. That is also not significant. So we don't have a significant interaction effect. We don't have a significant main effect of breakup. We do have a significant main effect of relationship status on loneliness now. So how you would follow up on this, right, is basically we know that there's three levels of this factor relationship status. And we know that at least one of the means, group means, is different from the other group means, but we don't know exactly which one. So we're going to have to conduct pairwise t-tests, just like what we did in the one-way ANOVA. But first, we're going to probably want to see what the means look like. And to do that, you're going to go t-apply. And then we want the dependent variable, which again is going to be loneliness now. Put in your independent variable. In this case, we're looking at relationship status. And then we want the means, right? We want the means. And if we look at that, we can see that these are the loneliness averages, the mean loneliness in each of these groups. So for people who are in a relationship, they have a loneliness of 7.5 on average. For people who say it's complicated, they have a loneliness of 5.25 on average. For people who are single, their loneliness is 5.75 on average. Now, this doesn't really make a whole lot of sense. These data are just completely made up. So you wouldn't really expect that people in a relationship are somehow saying that they're more lonely on average than people who are say it's complicated or they're single. Um, But either way, we'll just take it at face value. We still don't know. Just looking at the means, we can guess, well, people who are in a relationship might be lonelier than these other two groups, but we don't actually know if any of these are significantly different from each other yet just by looking at the means themselves. So we need to run a pairwise test. Okay, well, how do you do that? Well, that's pairwise dot t dot test. Pairwise dot t dot test. And you put in your dependent variable first, your dependent variable first. That's going to be loneliness now, comma. Then you're going to put in your independent variable. In this case, we're looking again at status. Then you're going to have to put this p dot adjust dot method. P dot adjust dot method equals, and then quotes Bonferroni. We did this before with a one-way analysis of variance, and this is what we're doing right now, is just looking at the main effect of relationship status, which is just a three-level independent variable looking at loneliness. And so, in effect, this is a one-way analysis, or one-way ANOVA analysis. And we're doing the pairwise test. Let's see what happens. Okay, so. This is telling us that people who say it's complicated compared to people who say they're in a relationship, this is a significant difference. So the numbers that you're seeing in this table are p-values. So p of 0.0014 is less than 0.05. So it's saying that people who are in a relationship have a significantly different mean loneliness than people who say it's complicated. And if you look up right here, that's saying that 7.50 in loneliness is significantly higher than 5.25. That's what that's saying. How about people who say they're single compared to people who are in a relationship? Well, that's also a significant p-value, less than 0.05. So let's go back up. People in relationship, 7.50, versus people who are single, 5.75. Those two values, those two means, are also statistically significantly different from each other. How about the last possible pairing of people who say it's complicated versus people who are single in terms of their loneliness currently? No, this p-value is not significant. That is not less than 0.05. So 5.25 and 5.75 are not statistically significantly different. Okay, cool. So that's basically where you would stop with this factorial ANOVA, because we don't have a significant main effect of breakup, and we don't have a significant interaction between relationship status and breakup. So basically, you would stop there. Okay, we figured out that there is a significant difference, a significant main effect of relationship status on loneliness now, such that people who are in a relationship experience more loneliness on average compared to people who say it's complicated and people who say they are single. Of course, again, those numbers are all just made up. If you wanted to look at the means for these other groups, we can just check that out real quick. We know that they're not going to be statistically significantly different because the p-values are not different. Or I'm sorry, the p-values are not significant. They're not below 0.05. They're quite far above 0.05. So the means that we're just about to find out are definitely not statistically significant, but we could just do it anyways for practice. Whoa, I don't know what that was. Okay, independent variable here is again loneliness now, but this time we're going to be looking at not relationship status, we're looking at breakup. So whether you're the dumper or the dumpee and whether that affects loneliness. So then we go mean. Okay. People who did the dumping in their previous relationship have an average loneliness of 5.83. People who were, oh, I'm sorry, no, that's the people who were dumped, the dumpee. The people who were dumped have a current loneliness of 5.83. People who did the dumping, they are the dumper, they have a current loneliness on average of 6.50. And again, that doesn't quite make a ton of sense. It could, I guess you could make an argument for that. But either way, we know that these means, these averages of loneliness, are not statistically significantly different because the main effect for breakup has a non-significant p-value. So we're not worried about that. So we would kind of ignore that. We can also look for uh, we can also look for all of the condition means, which would tell us something about the interaction. So we can look for all of the means that have something to do with the interaction. So what I'm going to put in here, this is something new that we haven't seen exactly how to do this. So first of all, you always put in the dependent variable, which is loneliness now. But this part is going to be a little bit different. I type out the word interaction and I put in a new set of parentheses. Then I'm going to put in both of the factors, both of the independent variables, which is status, comma, status, comma, and then we're going to do breakup. And then outside of that set of parentheses, we're going to do mean like that. Boom. Okay. Now remember, this is what's called a 3 by 2 design because there's three levels of relationship status and two levels of breakup. So 3 by 2. Well, if you multiply 3 times 2, you get six different conditions, right? You can get somebody who's in a relationship, but they were the dumpee in the last breakup. Somebody who's in a relationship, but they did the dumping in the last relationship. Somebody who says it's complicated and they got broken up with. Somebody says it's complicated, but they did the breaking up. Somebody who's single and they got broken up with, and somebody who's single but did the dumping in the last relationship, right? So you get six different conditions, and that comes with six different condition means. These are means, again, of loneliness. Um, so you can take a look at them and see, okay, well, it looks like somebody who's in a relationship and did the dumping maybe has higher loneliness than all of these other groups, but we already know that this interaction is not significant. So in fact, these means are not different from each other. We know that from right back up here, this line is talking about the interaction and the p-value is above zero point 0.05, so it's not significant, meaning that none of these are statistically significantly different from each other. Okay, so that was our first factorial ANOVA. Yay, yay, yay. Congratulations. We're going to do another one now that actually will have a significant interaction term, and then we're going to kind of follow up the steps to do some follow-up testing on that. Okay, so in this next set, we're going to have to create a new model. And what we're going to be looking at is specifically, we're going to keep breakup. We're going to keep that, which is 2 levels. And now we're also going to look at attachment, whether somebody's insecure or secure. And we're going to look at the dependent variable, the outcome of satisfaction. So you could say something like somebody who did the dumping in the last relationship and has a secure attachment style has the most satisfaction. So you would say something like, I think that people who did the dumping in the most recent relationship have higher satisfaction ratings, but it's dependent on whether their attachment style is secure or insecure. So only people who did the dumping but are also secure will experience the highest levels of satisfaction, and that means there's an interaction effect, all right? Or if we found that there was an interaction effect, then we could follow up on that. So we're going to have to create a new model, okay? And we can call this one whatever we want. Maybe you can call it satisfaction one. Maybe I'll just put in status one just because I like shortening stuff for model names. So status one is going to equal AOV. Again, that's the function for analysis of variance. And in this case, we're going to be doing the dependent variable of satisfaction. And then you actually do a tilde, right? A tilde. And then your first independent variable in this case is going to be breakup plus the second independent variable, which is going to be attachment, plus the interaction term. And so you have to do factorial. Again, I'm just specifying data frames and the particular column. So that's status colon, status by breakup. No, 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 no. Oh, that's not what we want. That's not what we want. Breakup by attachment. That's what I'm looking for. Breakup by attachment. Factorial ANOVA. And we're looking at attachment. Yeah. Okay, dokie. So you can see that status one. Oh, that's kind of annoying. I didn't realize this is relationship status. This is satisfaction. So yeah, we're good. We're good. Okay. Satisfaction. And then we do summary. Status one. Summary of that. And here we go. Okay, so this is the factorial ANOVA output. Again, we have just asked R to essentially make three different tests all at the same time. The main effect for breakup, whether people who are the dumper or the dumpee have significantly different satisfaction ratings on average. And in fact, it looks like they do because this value, 5.39 times 10 to the negative seventh, is going to be very small number, way lower than 0.05. The main effect for attachment, to see whether people who are insecure or securely attached have significant differences in satisfaction on average. Yes, that also is significant. 8.99 times 10 to the negative seventh is a very small number, much less than 0.05. And the interaction term between breakup and attachment in terms of satisfaction is also significant. 1.51 times 10 to the negative sixth is smaller than 0.05. Wow. Okay, so we got two significant main effects and a significant interaction term. That's pretty amazing. So you could approach this in a few different ways. The first thing you could do is if you were interested in the marginal means, you can go ahead and do T apply, and that will then get you the means. Let's just do that for breakup real quick. So the means we're going to put in outcome, comma. We're going to look at breakup, and we want the mean. Okay. And so we can see here, if we're looking for satisfaction ratings, people who were dumped, people who were dumped in the last relationship have a higher satisfaction rating than the people who did the dumping. Okay. People who were dumped on average have a higher score. And we know that this is a significant difference. You don't even have to do like a follow-up, pairwise t-test or something like that. Why do we know that this is different? Well, there's only two levels here, and the main effect of breakup is significant. So that basically is saying that this did a independent samples t-test essentially. So we know that these two means are statistically significantly different. Very cool. Now, what if we wanted to check out the main effect of attachments style on satisfaction? Okay, so satisfaction. Now we're going to go with attachment, find the mean, satisfaction. And here we go. People who are insecure have a lower satisfaction compared to people who have a secure attachment style. Okay, well, that might make some sense. Do we know that this is significant? Yes, we do, because the main effect, which is basically an independent samples t-test, tells us that it's significant, so that these two things are statistically significantly different from each other. But you don't really oftentimes in psychology care about the main effects so much if the interaction term is significant. And why is that? It's because the main effects themselves are independent of each other, meaning that like if you're just looking at somebody's how somebody's attachment style relates to their satisfaction, well, you're actually missing very important information because there's a significant interaction. It means that if you only look at the main effects of attachment on satisfaction, you're basically missing the effect of breakup interacting with that. And so it's a incomplete information basically. It's like you're not getting the full picture if you only look at the main effect. You want to look at, in fact, the interaction term. Okay, so how are we going to do that? Well, first of all, you want probably the means. You want the condition means for every condition that we have. And what kind of design is this, by the way? We've got two levels for breakup and two levels for attachment. So this is a 2 by 2 ANOVA. Okay. And so we would expect 2 times 2, we'd expect to have 4 different condition means. And let's see if that is the case. So T apply, you're going to again do your, it's always dependent variable first, satisfaction in this case. Now I'm going to put in interaction, then put in my first variable, which is breakup, second variable, which is attachment. And then outside of that first set of parentheses, I put comma mean. So here we go. In a 2 by 2 design, you would expect 4 different cells, 4 different condition means, right? So for people who got dumped and are also insecure in their attachment style, their satisfaction is 4.33 on average. People who did the dumping in the previous relationship and are insecure in their attachment style have a satisfaction of 4.0 on average. People who got dumped but have a secure attachment style have a satisfaction rating on average of 13.5, which is quite high in this case. And then people who did the dumping and have a secure attachment style have a satisfaction rating on average of 4.17. So that's cool. So we know that the interaction effect is significant, which means that at least one of these condition means is significantly different from the others. And in fact, multiple of them could be different from other ones. But we don't know just by looking at these means. And so we have to actually look at what are called the simple effects, essentially breaking this down into pairwise comparisons between all of these conditions. Okay. So how do you do that? Well, with our good friend pairwise t.t.test, right? Pairwise t.test. In this case, you're going to put in the dependent variable first, and that would be satisfaction. Then you go comma, you write out the word interaction. You're going to put in the first independent variable, also known as a factor, which in this case is breakup. And that's going to be comma, second factor, which is attachment. Right? And then outside of that set of parentheses, we have to put a comma and then p dot adjust dot method. P dot adjust dot method quotes Bonferroni. Bonferroni. Okay. And we hit enter and boom. This gives us a bunch of different pairwise comparisons, right? It's going to have all of the possible pairwise comparisons in it. And what we can see is that for people who were the dumper and are insecure, let's see, people who were, compared to people who got dumped and are insecure, that is not a statistically significant p-value. That, I mean, 1 is as high as it goes. So no, those two are not different. And what were those two? Dumper insecure and dumpee insecure, 4.33 and 4.0 in terms of average satisfaction. Those are not different from each other. Now, somebody who got dumped but has a secure attachment style is statistically significantly different from somebody who got dumped or the group that got dumped but is insecure. Okay. So people who got dumped but are secure, this is different than people who got dumped but are insecure. So 13.5 is statistically significant from 4.33 in terms of satisfaction on average. Same thing with the secure people who got dumped, as well as dumper insecure. So people who did the dumping but are currently insecure. So 13.5 is statistically significantly different than 4.0 in terms of average satisfaction. And finally, the dumper who is secure is statistically significantly different from the dumpee who's secure. So 13.5 is statistically significantly different from 4.17. So basically what we found is people who got dumped but have a secure attachment style have the highest satisfaction rating. It's higher than any other group. But also, if you're looking around at all the other comparisons, none of them are significant. So none of these other groups are statistically significantly different from each other because that's where you see all these ones. Okay, very, very cool. So basically, we've just found out that in fact, yes, we have a significant main effect of breakup on satisfaction, a significant main effect of attachment on satisfaction, and a significant interaction term such that people who were dumped but are currently have a secure attachment style have the highest satisfaction rating. That was different than the original hypothesis I had. I thought that people who did the dumping did the dumping and had a secure attachment style would have the highest satisfaction. That's not what we saw. It was still a significant interaction, so you would still reject null hypothesis about interactions. But I was wrong. In fact, this particular group, people who got dumped but are secure in their attachment, has the highest satisfaction rate. Cool. All right. I hope that was interesting. You will definitely want to know how to do this, how to interpret certainly these results, how to find um, the marginal means as well as the condition means, and how to interpret the output. All right, y'all. Have a good one. I'll see you in the next video.